Aloha and welcome to this brief screencast on coding standards. Frankly, I'm a huge fan of coding standards. In fact, I think that if there's only one thing you're going to implement to affect the quality of your software, if you're only going to do one thing, then that one thing should be a coding standard. Everything else is not going to work very well if you don't first implement a set of standards for how your code is going to look and how it's going to be written, and then enforce that. Once you do that, you can scale beyond one person and have the code maintain some uniformity because everybody is coding in the same fashion. Also, it becomes incredibly more readable because people will see the code looking the same way at all places in the code. Finally, when you implement coding standards, you're typically implementing things that either prevent the occurrence of or detect the occurrence of common anti-patterns, bogosities in your code for a given language. All languages have certain kinds of constructs that might be syntactically legal, but are obviously wrong. Like, for example, in languages, if you use a variable before you've declared it, oftentimes syntactically that's okay, but of course that's going to lead to a runtime error, and coding standards and their associated tools can oftentimes find those kinds of things pretty easily. So coding standards are huge, and I hope that one of the main things you get from this class is no matter what language you work on in the future, you should be using a coding standard. Okay? Having said that, I'm not going to lie, if you don't have tool support, it's pretty impossible to enforce a coding standard. Okay, it's really, I mean, you can have code reviews and so forth, but if you're using code reviews to enforce a coding standard, then your code reviews are really ineffectual because you're dealing with low-level syntax things that are going to occupy all your time, and you're never going to get to the big things. So you really don't want to use humans to enforce coding standards. You really want tools to do it. And there are a lot of tools out there. I'm going to show you a few, but the important things are, after you need a tool, you not only need to have the tool, you need to run the tool regularly, and then you need to actually listen to the tool and remove the errors that it finds. And that turns out to be, oftentimes more problematic than you might think. People will have the tool and they'll just blow it off. Okay, so don't do that. Okay, so the good news is really for almost any modern language, there are tools to implement and enforce coding standards, and they're usually configurable, so they don't force you to obey a single coding standard, but you can kind of write rules to define whatever coding standard you feel is appropriate, and then the tool will enforce that. These are usually called lint tools, or something based, that has lint in it someplace, PyLint, eslint, blah, blah, blah. And the reason for that is that in the very early days, the Paleolithic era of software development, when everybody was programming in C or worse, assembly, the folks that wrote the original C compiler or the early C compilers realized that it would be nice to have a tool that they could run over their programs to detect certain classes of errors, and they called that lint. Okay, so this is the seminal coding standard compliance tool, and that's why so many times when you see the name of a coding standard tool for some other language, it's going to incorporate lint into it. Though the first one I'm going to show you does not use the word lint, but it is the kind of canonical coding style tool for the Java programming language. It's called checkstyle, and hopefully if you've been programming in Java, you've already been aware of this tool. Okay, if you're programming in Ruby, the most common code style compliance checker is called Rubicop. For Python, it's called PyLint. There you see the lint. And then for JavaScript, the one we're going to be using is called eslint. ES is abbreviation for ECMAScript. ECMAScript is the name of the standardized version of JavaScript. So, in case if that's been confusing to you, you can hear ECMAScript, just think JavaScript. If you hear JavaScript, just think ECMAScript. except if it's a really old version of JavaScript and then there was no ECMAScript for it. But anyway, the eslint is a linting facility for ECMAScript. Okay, so lots of tools for all sorts of different languages. How are we going to do it in this class? We're going to basically do it in two ways. The first way is through the use of a XML, a standardized code style that you can import into IntelliJ, which does things like specifies how many spaces to use for indentation, and where there should be wrapping and braces and blank lines and so forth. Okay, so you'll see in the experiences that you can download this XML file, import it into IntelliJ, and then if you set it for your project, like you can see here it's set, then the nice thing is you can just type Option Command L and all the code will be reformatted if necessary to be laid out that way in your buffer. Okay, so that's one huge win for getting your code to be laid out correctly. The second piece of it, which is much more kind of comprehensive, is that we're going to use eslint in this class. We're going to integrate it into IntelliJ so that when you're looking at your code in a buffer, the eslint program will be running in the background and flagging errors as it sees them and showing you the line on which they occurred and what the error was, making it very, very easy to detect and remove errors. And the specific set of coding style guidelines we're going to use is called the Airbnb code style document. And so assuming that you've set up your eslint the way that I recommend, then you'll be able to have a .eslint.eslint.rc file which says your rules are simply going to extend this Airbnb-base set of rules, and then we'll make a few minor twiddles here for our class. But for the most part, it's just going to be our Airbnb code style. So that's how we're going to do it. Basically, two pieces to getting your code to look just gorgeous. So we have tool support, but as I said before, there's two other things to really make your quality go up. First is you got to actually invoke the tool, and secondly, you have to ensure that once you've invoked the tool that you actually fix the errors that occur. Okay. And for right now in the semester, it's going to be kind of manual, right? So you're going to, the tool will be integrated in IntelliJ, but so that you don't really have to invoke it yourself. IntelliJ will take care of that, but you have to ensure that the errors get removed, and the way that I will help incentivize you to do that, get in the habit of doing it, is by deducting points when we check out your code if we see that there are any eslint or other coding style errors that exist. Now, of course, that's not a good long-term solution. You're only going to be in this class for a few months. The longer-term solution in a professional development scenario is this thing called continuous integration, and the notion is that when you check in your code to your repository, be it GitHub or some private repository, you automatically invoke a build tool that will invoke your code quality tool on your code and then fail the build if any errors occur. And that's basically the standardized solution. We won't get to continuous integration until late in the semester, so for now the goal is just integrate the tool into IntelliJ so that you're seeing the little red arrows show up when you have a problem, and then just click on it and remove it. No big deal. All right, see you soon.